Deep within the dense, emerald expanse of the Peruvian Amazon, a pale mist rises above the jungle canopy, masking a lethal anomaly. Here, the water does not merely flow. It simmers, roils, and violently churns at temperatures reaching 93 degrees Celsius, just shy of boiling point. Frogs and insects that accidentally slip from the overhanging foliage are killed instantly, their bodies cooked in the current. This is no ordinary waterway. Known to local indigenous communities as Shanay Timpishka, which translates roughly to boiled with the heat of the sun, this 4-mile stretch of water defies standard geological models. For decades, it was dismissed by mainstream science as a myth, a tall tale spun from the humid depths of the rainforest. Yet, the boiling river is entirely real, carving its path through a region completely devoid of active volcanoes. In typical geothermal systems, superheated water is the direct result of proximity to magma chambers. Yellowstone and Iceland boast spectacular geysers and thermal pools, but their heat sources are obvious and shallow. The Peruvian Amazon, however, sits hundreds of miles away from the nearest volcanic center. The existence of such immense thermal energy here challenges our fundamental understanding of continental heat flow and subterranean hydrology. The secret lies deep within the Earth's crust, driven by an extraordinary network of fault lines. These deep-seated fractures act as a massive hydrothermal plumbing system. Rainwater falls on the distant Andes Mountains, slowly percolating downward through porous rock over thousands of years. As it descends deeper into the crust, it is subjected to the natural geothermal gradient, absorbing the immense heat radiating from the planet's mantle. Once this subterranean water reaches critical temperatures, immense pressure forces it back toward the surface through a major fault line. It surges upward at an astonishing velocity, retaining almost all of its thermal energy. When it finally breaches the jungle floor, it erupts as hot springs that feed directly into the Shanay Timpishka. The sheer volume of this superheated discharge is what transforms a cold jungle stream into a boiling torrent. Navigating the banks of this extreme thermal anomaly is an exercise in profound caution. The surrounding mud is frequently scalding, and a single misstep can result in severe, life-threatening burns. Dense clouds of vapor obscure the treacherous terrain, creating a disorienting, sauna-like atmosphere that saps human endurance within minutes. The air is thick with the scent of damp earth and cooking vegetation, a constant reminder of the lethal waters below. Yet even in this hostile cauldron, life refuses to be entirely vanquished. While the main channel is a death zone for complex organisms, the cooler margins where thermal waters mix with ambient streams harbor a hidden biological frontier. Here, scientists have discovered thriving communities of extremophiles, microorganisms evolutionarily engineered to survive and even flourish in conditions that would denature the proteins of almost any other living creature. These specialized microbes rely on unique biological mechanisms, including heat shock proteins that maintain cellular integrity at blistering temperatures. Instead of relying on sunlight for energy, many of these organisms utilize chemosynthesis, extracting metabolic energy from the rich array of dissolved minerals and sulfur compounds welling up from the deep earth. They form vibrant, colorful mats along the riverbed, painting the shallow edges in striking hues of green and orange. Analyzing these resilient life forms offers more than just biological curiosity. The extremophiles of the boiling river provide a living window into the distant past, mimicking the harsh, primordial conditions of early Earth. By studying their genetic blueprints, researchers hope to unlock the secrets of how life first originated in ancient hydrothermal environments. Furthermore, their unique enzymes hold immense potential for revolutionary applications in biotechnology and medicine. Documenting this extreme ecosystem requires immense physical and technical dedication. Expeditions into the Shanay Timpishka involve hauling heavy scientific equipment through dense, trackless jungle, battling oppressive humidity and the constant threat of tropical disease. Researchers must wear specialized protective gear just to approach the river's edge, using extended probes to gather water samples and measure the staggering thermal gradients without falling victim to the collapsing, unstable banks. The physical toll of sustained research here is staggering. Dehydration occurs rapidly, as the ambient heat of the jungle is compounded by the relentless radiating steam of the boiling river. Explorers must constantly monitor their core temperatures and maintain a hyper-vigilant state of situational awareness. The roar of the rapids drowns out communication, isolating team members in a volatile landscape where the margin for error is absolutely zero. This massive transfer of heat dramatically alters the immediate microclimate. The constant evaporation creates a localized greenhouse effect, perpetually bathing the surrounding flora in warm mist. Trees and vines that lean over the water are coated in a permanent layer of condensation, fostering specific types of mosses and epiphytes that thrive in this hyper-humid zone. The river effectively engineers its own atmospheric pocket, distinct from the broader rainforest. The tectonic forces required to maintain this geological system are almost incomprehensible in scale. The fault lines beneath the Amazon are ancient scars, remnants of the South American continent's turbulent history. These fractures reach depths of miles, plunging into regions where the Earth's internal heat is intense enough to melt rock. The water acts as a thermal conveyor belt, transporting that deep crustal energy directly into the biosphere. What truly separates the Sinai Timpishka from other geothermal sites is its sheer volume and flow rate. Most non-volcanic hot springs produce a modest trickle or a localized pool. This anomaly, however, sustains a boiling river up to 80 feet wide and 16 feet deep in places, flowing continuously for miles. The mathematics of such heat transfer demand a subterranean reservoir of staggering proportions, a hidden ocean of superheated water. The surrounding jungle has been forced into a strange, evolutionary compromise with the heat. Certain plant species along the banks have developed thicker, more resilient bark to shield their vascular systems from the rising steam. Root systems diverge sharply away from the hottest soil zones, seeking cooler, shallower ground. It is a silent, slow-motion battle for survival, where the flora must constantly adapt to the shifting boundaries of the thermal radiation. This delicate balance is heavily influenced by the Amazon's dramatic seasonal shifts. During the torrential rains of the wet season, the river's temperature drops slightly as massive volumes of cool surface water dilute the geothermal upwelling. But in the dry season, the true fury of the anomaly is unleashed. The water levels recede, concentrating the thermal energy and turning the river into an undiluted stream of scalding destruction. Isotopic analysis of the river has yielded a fascinating revelation about its origins. The chemical signature of the water proves it is meteoric, meaning it originated as atmospheric precipitation rather than ancient trapped ocean water. This confirms the staggering journey the water undertakes, traveling hundreds of miles laterally and miles vertically. It is a continuous, ancient cycle of rain, deep subterranean heating, and violent resurgence. To visualize this geological process is to understand the Earth as a dynamic, interconnected machine. A single drop of rain falling on a snow-capped Andean peak embarks on a subterranean voyage lasting millennia. It is squeezed through microscopic pores in the bedrock, heated by the radioactive decay within the mantle, and finally expelled into the humid embrace of the Amazon. The river is the fiery conclusion to an epic odyssey. Because of its lethal temperatures, the main channel acts as an impassable barrier for many terrestrial and aquatic species. It is a liquid wall of heat that fragments habitats, creating an isolated ecological island. Predatory mammals and reptiles instinctively avoid the corridor, learning through generations of observation that the pale mist signals certain death. The river shapes the biological landscape not through nourishment, but through absolute exclusion. Modern geological surveys employ advanced thermal imaging drones to map this hostile environment from above. These aerial platforms pierce the dense canopy and steam clouds, revealing the precise fault lines and upwelling zones invisible from the ground. By correlating this thermal data with satellite topography, scientists are slowly unraveling the complex geometry of the subterranean fractures, piecing together the hidden architecture that fuels the anomaly. Down in the cooler shallows, the genetic goldmine continues to yield surprises. Researchers have identified strains of bacteria that produce novel defensive compounds, weapons forged in the evolutionary crucible of extreme heat and heavy metal toxicity. These microscopic survivors represent an untapped library of biological innovation, Their resilience proves that life does not merely endure severe environments, it actively exploits them, turning lethal challenges into evolutionary advantages. Yet, the Shinai Tempishka remains a fragile geological phenomenon. The delicate pressure systems that drive the subterranean river could be disrupted by excessive deforestation, which alters the water table, or by deep earth resource extraction. The very isolation that protected this anomaly for millennia is slowly eroding. Understanding the intricate mechanics of this thermal river is now a race against time, as modern development encroaches upon the deep Amazon. Ultimately, this boiling waterway stands as a profound testament to the planet's hidden, raw power. It shatters our preconceptions of where immense energy can manifest, proving that the Earth's fiery heart can reach out and touch the surface far from any volcano. The Shinai Tempishka is a beautiful, terrifying anomaly, a place where the deep crust breathes fire into the jungle and where life, against all odds, finds a way to hold the line.